Greetings and welcome, friends. We've been solving systems of linear equations using substitution, a wonderful, accurate, algebraic means to come to a solution. Here's a problem. Here's a system. It's a system because there's two or more equations. Notice I've got two variables in each of these, and I, in finding the solution, want to find the x-y combination that makes both of these equations true at the same time. So step one was solve one of the equations for one of its variables. Notice this equation's already solved for y, and this equation's already solved for y. So step one is done. All right. Although you are free to solve for x if you want to, but neither of those x's would be helpful. It'd create some unnecessary fractions. Question, comment? All right, yeah, what did you do? Walk me through it. Yeah? Okay. Oh, okay. So you're taking this, which is equal to y, and plugging it into the top equation's y. Cool. All right, so you got something like 6x minus 9 equals negative 3x. And now what do I do? Sure. It's not what I would do, but it's perfectly fine. Okay. Yep, so I'll have 6x equals negative 3x plus 9. Yep, bring those x's together. Add 3x, I like it. 9x is equal to 9. Oh, I know this one. What do I do? Both sides by 9, and I get x equals 1. I'm done, right? No, I'm only half done because I want x and y. So if x is equal to 1, that means I can now plug 1 in either of the original equations for x. Which one did you pick? Yeah, the bottom one's a good choice. In this case, they're actually both pretty good choices because they're both solved for y. So step 3 is that additional substitution I'm doing. So y is equal to negative 3 times x, and instead of x, I'm plugging in 1. So y is equal to what now? Negative 3. Well done. So my solution is 1 comma negative 3. That would be the point on the graph at which both of those lines exist, also known as their intersection. We'll do a quick check. I don't normally do the checks on these, but we'll show you what a check looks like. Is 6 times 1 minus 9 equal to negative 3? Let's see. So I plugged in the x and the y in the first equation. Question, comment? All right. Yeah, let's be friendly now, friends. Let's respect one another. Right? We are a community. It's wonderful. Relevant. We're like responsible. Right, we have respect. So hey, this is true when I plugged that in. So that means it works in the first equation. Does it work in the second equation? Yeah, I'll plug in negative 3 for y. Is that equal to negative 3 times x, which is 1? So here I'm checking the second equation. Hey, negative 3 equals negative 3. That's also true. Good news for us. Since it's true for both equations, that means it is the solution of the system. Right? It's got to work in both simultaneously. All right, I do have another video up with some of the other word problems, but here, yeah, that's self-referential. Oh, sorry, I'll scroll back. Flip the page. Flip the packet. Are you missing a page? I'm going to do 25. Someday I will have pumpkins. And okay, so here. All right, let's see. About... Yes. Oh, yeah. We have a question coming, audience. Oh, you're looking at the next one already. Okay, okay. Well, let's get to that. Yeah, okay. So variable. So I'm going to use the VESA method, right? Define my variables, write my equations, solve those equations, answer the word problem with a word answer. It says the following: a math test is worth 100 points and has 38 problems. Each question, or problem rather, is worth either 5 points or 2 points. Then they ask how many problems of each point value are on the test. So I'm going to let X, when I define my variables, it's usually like 95% of the time related to the question, unless they do like a sudden switcheroo at the end. What if they ask, like, you know, the last question was, how do you like 5-point questions? Like, you know, then that's obviously not going to be my variable. Or like, do you like math tests? Right, that question I couldn't use in defining my variables. But here I can. All right, so how many problems of each point value are on the test? So X will be the number of 5-point questions. All right, so this is a quantity. It's a how many, right, variable. And Y will be the number of 2-point questions. By the way, they often have problems kind of like this related to basketball game scores, and they'll be like, how many 2-point shots and how many 3-point shots did the team get? You know, and then, yeah, same idea. So let's define our equations, right? Our equations. So let's see, the first one, going to be my blue equation. It says the math test is worth 100 points. All right, so this is going to be an equation about points. The next place I see regarding points is that each problem is worth either 5 points or 2 points. So how could I combine all of my points information into an equation about points? Well, total is 100. What's that 100 made out of? Where do I find those points? Yep, 5 points multiplied by the number of 5-point questions. Right, this term would represent the total number of points from those 5-point questions. Yep. Then what? Plus 2y, right? 2 points multiplied by the number of 2-point questions. That gives me the number of points from all of those. And if I add those two things up, that's going to be the total points for the test. I like it. All right, let's write another equation. Then this next equation is related to how many. So the test, right, has 38 problems. Okay, so this is going to be related to what I call quantity. Quantity, all right, or how many, okay? So the total number of problems is 38. How could I write an equation related to that? Yeah, just plain old X plus Y, right? The number of 5 points plus the number of 2-point questions is the total number of questions. Are you guys feeling that? Is that? I mean, I know writing the equations and defining the variables is the toughest part, but I think we're getting it. Let's see if we can solve this. No, quiz will be even easier than this. The quiz would be like if this was already given to you, and then you just have to solve it. So it's the substitution part that I'm got the mini quiz today for. So let's see. Step 1 at subs. Solve one of the equations for one of its variables. Let's see. Targeting. Which variable of these 4 slots should I solve for? I like this equation better, right? I don't want to solve for this because I'd have to divide at some point. That creates fractions. I don't want to solve for this. I'd have to divide. That creates fractions. I don't know where that came from. Yeah. So guys, let's solve for this equation's y. How about? All right, gentlemen, you with me? You with me? Let's solve for this equation's y, although the x is just as good of a choice. Why do I like these? Because they have a positive 1 or a negative 1 coefficient. If I had a negative 1 choice, that would have been fine too. So to solve for that equation's y, yeah. Yeah, that does not matter whatsoever. That does not matter whatsoever. Actually, you also could have had different variable names. You could have called this S and T, or right, B and C, or I don't know. You could have come up with any variable names that you wanted. Okay, so I just solved for one of the equations. Step 2 is this, that if these two things are equal, if y is really equal to that, that means I can plug that in to the other equation's y. So I'm going to replace the other equation's y. This is the substitution part, like so. So let's see. So 5x plus 2, instead of y, I'm going to have something equals 100. And so instead of y, I'm replacing it, the old switcheroo. This morning when my wife woke up my sons, one of them, the youngest, complained that the middle, stole something from him. He's like, he stole my bunny. He went like this. And then he like proceeded to act out like this with like grabbing, reaching with his arm. And he said, stole it, as he like did the stealing motion. It was pretty good. Stole it. Pretty good. I liked it. Sound effects when you steal things. Usually, I do the classic Homer Simpson yoink, like when you steal a donut from, I don't know, a carton of donuts for some reason. Let's see, let's distribute here. So anyways, 5x, minus 2x, plus 2 times 38, 76. You could reach for a calculator for this. You also have a calculator on your mini quiz, just so you're aware. Now what should I do to solve? What could I do? Combine. I like it. Yeah, let's get these x's together. 5x's minus 2x's is how many x's? 3 x's. Okay, now what do I do? I would subtract that 76 from both sides. 3x is equal to, what's that, 24? Oh, and then you're solving it already. Nice. So even if you chose to solve for x instead of y, you would have different work, but you'll actually end up getting the same values of x and y at the very end. So yeah, x equals 8 is my answer. Now, if x equals 8, I'm not done. I'm looking for x and y. Where should I plug this in? I could plug it in here. I could plug it in here. Best place, yep, is right here. This is the best place because this is already solved for y, which is what I'm looking for, the other variable. You would get the same answer if you plugged it in anywhere. Isn't that great? How much work you want to do? The easy way or the hard way? Right? And as a mathematician, I'm an efficiently lazy person. Negative 8 plus 38 is 30. So that means my solution is 8 comma 30. What do those mean? What does 8 and 30 mean? Eight, yeah, is the number of 5-point questions, and 30 is the number of 2-point questions. So let's answer that with words. Right? And the way you can find that out is if you define your variables well, you can then answer the question very easily. So there are 8 5-point questions and 30 2-point questions. So I think the toughest part is being able to write those equations right after you define those variables. Hopefully you guys are getting a little bit better at the substitution part. Let's do one more. I'll hang out for a minute. Tell you what, I'll have a sip of coffee. Oh dear, my coffee's running low. I'm gonna. Oh, it's almost noon though. I guess I could finish off my coffee now. I'll make it through the day. Yeah. This episode of Waddy Math is brought to you by Aldi's Coffee. Cheap caffeine. So, let's look at one more problem. We'll see how far I get. How many minutes am I at? 15. I might just do V and E on this one. We'll see. Okay. Okay. All right. It says the sum of the digits of a two-digit number is 11. When the digits are reversed, the number increases by 27. Find the original number. Oh my goodness, this is tricky. All right, so my variables, I should have x be the, let's see, it's a two-digit number. So I could have x be the tenths place. Oh, this one is tricky. And y is the ones place. Okay. And one thing I just want to point out is my number would then equal, I can't just write xy. It would actually be 10x plus y, which I don't think is obvious. I don't think that's obvious. Yeah, this one is tricky. The reason this is true, let's say my digits were 3 and 2, and I'm thinking of the number 32, right? Okay, let's say if that was the case. If I said that the number was 3 times 2, that would be 6. Right? The actual number, 32, is equal to 3 times 10 plus 2. Right? For this digit 3 to be in the tens place, I have to multiply it by 10. That's a little tricky. All right. This is just like to help me find my answer. Okay, it says the sum of the digits is 11. What does sum mean? Total? All right. So x and y, what am I doing between those to get 11? What is... Yeah, sum is going to be addition. All right, so it says the digits add to 11. It says when the digits are reversed, oh my goodness, that is tricky. The number increases by 27. I wonder if I'm doing this the easiest way. I have no idea. Let's try it. Okay, so for the digits to be reversed, that means this time the y would be in the tens place and the x would be in the ones place. You guys agree? So for the digits to be reversed, I would be talking about the number 23. You guys agree? That's what they mean by reversing the digits. 23 would be something like 2 times 10 plus 3. Do you guys agree? Right? 2 times 10 is the 20 part, and the 3 is the ones part. Okay? So if the digits are reversed, I would say 2y plus x. And that is equal to the original number added by 27. So if I add 27 to the original number, but how do I represent the original number? This problem is really good. Wow. What did I describe my original number as? This part here. Okay, so I'm going to say this is the same as 10x plus y. That's my original number plus 27, right? 27 more than the original gives me the reversed digits of this. Okay. This is scary, guys. Isn't this one scarier? Okay. When I'm looking at this, I could rearrange this purple equation a whole bunch. Should we do that? Should we combine the x's and the y's? All right. I'm going to bring the y's over here, and I'm going to bring this x over there. How about? I could also bring all the x's to the same side as well. Are you guessing the answer? Well, hold off. Write it down somewhere, and we'll see if you get it right. This was like an example that is not the answer to my knowledge. I don't know what the answer is, but I'm pretty sure these are not differing by 27. So let's see. Let's subtract y from both sides. So my new purple equation would be 2y minus 1y is y. Plus 27. And then, what do you guys think? Where should I move my x? Let's subtract x from both sides, how about? There are very many paths you could have taken to do this problem. So I would have y equals 9x plus 27. Okay? Now, if that's true, where could I plug this? I would plug it into the blue equation's y. You also could have solved the blue equation for one of its variables first and done that route. Like I said, there's so many ways to do these types of problems. It's all about, do we obey the laws of math to get there? All right, so this was kind of my step 1, I guess. Step 2, I'm plugging it in. So x plus, instead of y, I now have 9x plus 27. Why don't I need parentheses for that? No? I don't need parentheses because there was no number in front of that y. Right? It was just a 1. And if I did put parentheses, 1 times those is still 1.